So here we are in Desmos, and I want to show you how you can check your solutions you got algebraically using graphs in Desmos. To do that, and by the way, we're going to double check the solutions we got on the last two equations using Desmos. So I've written those equations down on the left, and I've also written in the solutions we got. To do the check graphically, we want to graph the two sides of each equation independently. So the left side of the first equation was x times x minus 3. Now I want to say that that's equal to y so that I can see it on the graph. And then we're also going to show the right side as y equals 18. Now, you noticed you briefly saw a line come up when I had the 1 there, and then it disappeared. The reason it disappeared is that y equals 18 is the horizontal line at y equals 18, and we don't have y equals 18 on the screen here. So we're going to have to zoom out to actually see it, and there it is. So to see the intersections, if I click on one of the graphs, it will point out where I have intersection values, and I can click on them to actually see what those point values are. And notice the x values in those points, -3 and 6, match up with our solutions, because remember we were solving for x. So that checks the algebraic solutions that we got. Let's look at the next equation I have there on the left. The left side of that equation was y equals 4x cubed. So there's my first left side, and then y equals on the right 36x. Now, what I have is a really stretched out equation, and technically I can only see one of the intersections right now. I have an intersection at 0, 0. That does match one of my solutions, which was x equals 0, but it's hard to see everything here in the way the window is set up. You could try zooming out, but it's going to look really tight together. We can actually kind of see it there, but it's really hard to see. You can kind of see that there's a dot there, but you might not see that very well. So what I want to encourage you to do is when you're working with Desmos, don't just zoom in and out. Use the graphical settings by clicking on this wrench that's in the upper right-hand corner. So if we click on that wrench symbol, we can actually alter our x and y axis in a way that makes sense for the problem. Now it looks like this graph is stretched very vertically. So what I want to do is to make my y-axis, my vertical axis, go way up and way down. So maybe go -200 to +200. But my x-axis was not stretched. So I want to go to more reasonable values like -10 to 10. So I'm going to change this and make it so that the x and y axis are scaled differently. And when I do that, I get a much clearer image of how these two graphs are intersecting with each other. And I can very clearly see the intersection points, click on them, and actually see that I have intersections at x equals 3, x equals 0, and x equals 3, which matches the solutions I got algebraically exactly.